Now, in a square matrix, we know that if a square matrix of order n, there are n elements along the principal line. A line along which elements of the form that is aij, where I is less than j. We say that this line is known as super diagonal, and where I is greater than j, that is I equal to j plus 1, we know that it is subdiagonal. Now let us this square matrices, we see that the element are arrangement that is a11, a12, a13, a11. Now we check that in a square matrix of order n cross n, how many elements in the diagonal lines, that is in the first row. If we divide it by first diagonal, second, third, that is middle diagonal, we known as this diagonal is principal diagonal, that is where I equal to j. It is a principal diagonal of the matrices of order n. Now above the principal diagonal, that is where I equal to j, above this diagonal is known as super diagonal. Here we see that the number of rows is less than the number of columns, that is if I equal to 2, j equal to 3. Here I equal to j minus 1, that is the number of row is 1 less than the number of columns, then this diagonal is known as super diagonal of the square matrix. And we know previous that in the principal diagonal of the square matrix of order n cross n, it has n elements in its principal diagonal, that is in principal diagonal we say that here n elements are present. Then if we come across above the principal diagonal, the element in this diagonal are less than 1, that is in super diagonal we get n minus 1 elements, that is here in principal diagonal n element, super diagonal n minus 1 element. When we come across 1 above, we get n minus 2, that is n minus 2, n minus 1, n minus 2, n minus 3, and so on. The first diagonal is having 1 element. Similarly, along the below the principal diagonal, we see that this is principal diagonal and this is below the principal diagonal. Here the number of rows is greater than the number of columns, and here I equal to j plus 1, then this diagonal is called subdiagonal, that is the diagonal in the square matrix of order n cross n which is below the principal diagonal is called subdiagonal. Here we see that I equal to j plus 1, that is the number of rows is greater than 1 of the column, that is if row is 3, column is 2, and row is 2, column is 1, that is 1 more than the column, row is greater than the column 1 times. And if principal diagonal having n elements, super diagonal having n minus 1 element, then subdiagonal element has also n minus 1 element, that is we see that it along above, that is principal diagonal element, a principal diagonal have an element, then subdiagonal is n minus 1 element and decreases one element in every below diagonal, that is principal diagonal element, subdiagonal n minus 1, then n minus 2, and so on in last one element. Then clearly in a square matrix we check out the number of elements according to help of the diagonals, and we see that this representation by another small matrices of order n cross n. This is principal diagonal, this is above the principal diagonal, that is super diagonal, and this is subdiagonal. When I is less than j and when I is greater than j, we see that if we come across above the principal diagonal, then the number of rows is decreased in comparison to number of column, and we see that when we come across below the principal diagonal, the number of rows is greater than the number of column. Here we easily check out this is principal diagonal, right? If we come across above the principal diagonal, we see that the number of rows is decreasing, that is 1 2, here 1 3. The number of column is increases and number of rows is decrease. And similarly we come across below the principal diagonal, here the number of rows is increases more than in the comparison to column, that is row is 3, column is 2, here row is 3, column is 1, and so on. Then it is a pictorial representation of the square matrix of order n cross n to finding the element in principal diagonal, subdiagonal, super diagonal, and so on. Then it is most helpful, and there are so many questions attempt to competitive exams such as csir, nbhm, and so on for matrices to finding the number of element in square matrices. So as now in this picture we show that how many number of elements in the diagonals. In previous pictures we have always see that in the principal diagonal there are n elements, and there in the super diagonal there are n minus 1 element, in the subdiagonal there are n minus 1 element. Now if there are question how many elements in the diagonals, then we see that from this pictorial representation of a square matrix of order n cross n, we see that how many elements in the diagonals. If we see that according to this, that is we say that first diagonal, second, third, fourth, principal, and so on, then we check that how many numbers of elements in the diagonal are present. For this we see that in a square matrix of order n, the sum of row number and sum of column number lies between 2 to n, that is the number of the sum of row number and column number, that is here row is 1 and column is 1, then the sum of row number and column number is 2 here. Take. Now here the sum of row number and column number is 3. Then here if we see that the sum of row number and column number is 1, then the number of element in this diagonal is 1. Now if the sum of row number and sum of column number is 3, then we see that 2 1 and 1 2, there are 2 elements in this diagonal, that is if the sum of number of row and sum of number of columns is 3, then the number of element present in this diagonal is 2, and so on. In first we see that the sum of row number and column number is 2, there is one element. If sum of row number and sum of column number is 3, then there is 2 element. If sum of row number and sum of column number is 4, that is 3 1 1 2 2 1 3, then here we see that there are 3 elements, first, second and third. Then the sum of row number and column number is 4, then there are number of element present in this diagonal is 3. That is, we find idea for this. If sum of row number and column number is 2, then the number of element present in this diagonal is less than 1. That is, for 2 1 element, for 3 2 element, for 4 there are 3 elements, and the number of decreases, number of elements is increases in come across below on the principal diagonal. In principal diagonal we get an element, that is, for sum of number of rows and sum of number of column is equal to n plus 1. Then here we obtain the number of element in this diagonal is n. Now the number of elements will be decreases as we move below this row, that is, below the principal diagonal the number of element is decreases. Firstly is increases 1 2 3 and so n. Then after n it will be decreases 1 times per diagonal, that is, if we get n plus 2, the sum of row number and sum of column number is n plus 2, then we get n minus 1 element, and n minus 2 element, similarly 1 element. Then for this pictorial representation we get an idea for the square matrix to find the number of elements present in the diagonal. We get a diagram for this as like a formula, that is, the sum of row number and sum of column number is 2, then number of elements is 1, that is less than 1. Sum of row number and sum of column number is 2, then number of element in diagonal is 1. If sum of row number and column number is 3, then 2, that is 1 less than 1 2 3 and so on. When we get principal diagonal, there are sub number, sum of row number and sum of column number is n, then we obtain n minus 1. For n plus 1, that is principal diagonal, we get n elements, and similarly we get succeed this procedure, that is, sum of row number and sum of column number is 2, we decreases here n minus 1, that is, when we come across principal diagonal below, then we decreases the number of elements in the diagonals, that is n minus 1 n minus 2, and we last for sum of row number and sum of column number is 2n, we get only 1 element. We see that for this, that is, principal diagonal, n elements, below this n minus 1 element, that is n minus 2 element. For sum of n plus 3, row number and column number is n plus 3, then we get n minus 2 element. Here only 1 element in the last. Then we say that in a square matrix, sum of row number and column number lies between 2 to 2n, and the number of present in this diagonals are increasing order when we get 2 to n plus 1, that is, the number of element in this diagonal is less than 1. 2 in sum of row number and column number is 2, we get 1, then 2 3 and so on, and then we reach when principal diagonal we get n elements, and below the principal diagonal it is decreases, that is n minus 1 and so 1. Here from this figure it is very easy to check out the number of diagonal elements with the help of this table. Now we let us a question for number of diagonal elements in the matrices. The question is maximum number of different entries or elements in a square matrix A of order n, in which Aij equal to APQ if I plus j equal to P plus Q. Now we find the maximum number of elements in the square matrix A of order n, in which the given condition I plus j equal to P plus Q. For this we will solve this question. We know that the number of sum of rows and number of columns is vary from 2 to 2n. That is, we know that the value of I plus j is lies between 2 to 2n. For this we also know that each particular sum can have one distinct entry. That is, we see on the matrices in back, that is A11, A12, A1n, A21, A22, A2n dot dot dot, an1, an2 dot dot, ann. That is, in n cross n square matrix we also seen that the number of elements, the number of different elements in each particular diagonal element in which I plus j equal to P plus Q is 1. That is, we say that each particular sum can have one distinct entry. That is, if we put I and j equal to 1, that is 1 plus 1 equal to 2. Here we see that 1 plus 1, that is only one element which is also distinct, only one element. Then the question of distinct, there is no meaning. And when we put I plus j equal to 3, I plus j equal to 3, then we say that in the second diagonal, that is I plus j equal to 3, then there are two conditions, that is I equal to 2 and j equal to 1, and I equal to 1, j equal to 2. Then there are two elements, and the number of distinct entry for this question, there is only one element, because in this question both the elements are same. Then we take only one element, then 1 1 and so on. We see that from each particular sum can have one distinct entry. So the number of distinct elements is equal to number of distinct sum, that is total number of sum lies between 2 to 2n. Then clearly the number of distinct entry is 2n minus 1, because each diagonal element have only one entry. We see that it as, that is from given condition, if Aij equal to APQ, that is given condition in a question. For we see that if we put a11, then there is only one element in first diagonal. If we put a21 equal to a of 1 2, that is the number of element a21 and a12 is equal, and so on. We say that in the third diagonal, that is a31 equal to a22 equal to a31, that is here I plus j equal to 4, I plus j equal to 4, I plus j equal to 4. 3 elements are the third diagonal. Then 3 elements are equal. Then we say that here one element, here one element, and here one element. Then we clearly say that the total number of different element is 2n minus 1, because in the matrices 1 2 3 4 and in the diagonal there are n elements. Then n elements are present in this rows manner. There are total different n elements, and there are n different elements in columns. There are n plus n, that is 2n elements. But in this n elements are rows and elements are column, the principal diagonal elements are also common. Then we subtract one element and we get total number of different elements equal to 2n minus 1. Then the question, maximum number of different entries or elements in a square matrix A of order n in which aij equal to apq if I plus j equal to p plus q is equal to 2n minus 1.